Hey guys, yesterday we started taking a look at projectile and motion problems as it relates to quadratic relationships. And that's what we're going to continue to do today. So today what we're going to do is take a look at the path of a helicopter flight, and I bet you guys can guess what type of shape it would make on a graph. Let's take a look. So as you guys can see, the path this helicopter takes is very parabolic in nature. In fact, it is quadratic. So we're going to take a look at its equation and take a look at a few different types of word problems we might see associated with this type of problem. So go ahead and turn to page 92B in your notebook. And if you don't already have this, what you can do is print it out from the PDF attached to the slideshow. You can cut it and glue it right into your notebook, or you can just go ahead and draw this chart in your notebook on your own, but you do have to write in these headings as well as your equation. So let's take a look at the scenario. It says a helicopter starts its flight from the top of a hill. The height, h, in feet of the helicopter over t hours can be modeled by this equation. So then we're given a whole bunch of different related word problems. And what we want to identify is what part of the graph are they referring to when they ask these questions? How do we find that feature? And finally, the answer. So starting with the first question, how tall is the hill? If I look at the hill over here, the top of the hill is right here. Well, what point on the graph are we referring to right here? That would be the y-intercept. What is the clue that's telling us to use the y-intercept? Well, when they ask how tall the hill is where we're starting. It starts its flight from the top of the hill. So that means this question is actually asking for our initial value, right? So as I move forward here, what I see is that they're asking, when will the helicopter land? So where do we see that landing occur? It's right over here, right? So where does it land? Well, what key feature are they asking for here? The x-intercept, or the zeros, or the solutions. Now, how do we know? Well, again, they're asking for when it's going to land, and landing would be our ending point, right? So when we end a scenario, that's going to be referring to our x-intercept. What about the next question? The next question asks, when will it reach its maximum height? Well, what do you think we're referring to here when we say maximum height? Here we're talking about the vertex. So again, maximum, meaning, how tall is it going to get? Right here at the maximum would be the vertex. But here we wrote x value. Why specifically the x value? Well, if you guys remember, the vertex is composed of two parts, an x and a y, right? Every coordinate pair has both an x and a y. And only one of those numbers can be when it reaches its maximum height. So which of these two is the when? Well, it's the x and y. Well, because time is always independent. And so when they're asking for a when, they're going to be asking for an x value, okay? Because that's our independent variable. The next question here asks, what is the maximum height? Again, maximum. So again, they're referring to vertex, but this time they're just asking, what is the maximum height it's going to reach? Not when, but what. And so when they do this, they're asking for the y value of our vertex.